Hello everyone, welcome to this series of PYQ solution of CSAT papers. So far we have done 2 years paper, that is CSP 2024 and 2023. So now we are into 2022. So let us download the question paper from UPSC websites itself, and in this we have to see question by question. If you look at the question paper overall, this is bit a lengthy paper. Lengthy paper in the sense, like if you look at the length of each question, this is bit longer compared to other years. So first only you have to skim through the paper and look at the length of the questions, and you have to decide for yourself like which you have to take first. So definitely the questions which are a bit longer will be easier to solve, but the questions which are of 1 line, 2 line or 3 line, they'll be a bit difficult. But in this case, you will spend more time in reading these questions and might end up in losing the confidence a bit early. So better you have to take those shorter questions, though you take more time for solution, that's okay. But you need to get confidence from there. But let me go in order here. So first, an identity card has the number A, B, C, D, E, F, G. So there are seven numbers, not necessarily in that order, where each letter represents distinct digits. Each letter, 7 letters and 7 numbers. The number is divisible by 9. So the entire number is divisible by 9. So if you take this number, let's say there are 7 numbers in this. 7 numbers in this. In this, the entire number is divisible by 9. So how do you check the divisibility of 9? You have to add all the numbers and you have to see whether that sum is divisible by 9. So looking at these numbers, we have to anyways use these numbers. So make the sum. 1 plus 2 plus 4 is 7. 7 plus 5 is 12. 12 plus 7 is 19. 19 plus 8 is 27. 27 plus 9 is 36. Yeah, this entire number is divisible by 9. So these numbers can be interchanged. Their place is not like fixed. So they can be interchanged. Anyways, you have to get the sum as, so sum as 9. So anyways, you need not dearrange or arrange these one right now. You have to use all the numbers for sure. Next, after deleting the first digit, from the right, if I delete the first digit, we'll get the resulting number is divisible by 6. If the resulting number is divisible by 6, first of all, it has to be an even number. Even numbers given here are 2, 4 and 8. 2, 4 and 8. So this will be either 2, 4 or 8. And which number you are deleting? When you want this number to be divisible by 6, it has to be divisible by 3 also. So what kind of number you are removing? So you will have to remove the number which is divisible by 3. So in this, either 9 has to be removed or any other number, but there is no number which is divisible by 3. So you have to remove 9 only. So the last digit is 9. This particular digit is 2 or 4 or 8. 2 or 4 or 8. Let us wait because we have more options there. Next, after deleting last 2 digits, this one and this one, the resultant number is divisible by 5. So among these, like which all are divisible by 5? The number will be divisible by 5 when it ends with 5 or 0. So among these numbers, only 5 is that number which will give us the number divisible by 5 in this case. So here, again 5 here and try to arrange. When you put some number here, so it has to be divisible by 6 totally. But we cannot conclude anything right now by using 5 and some random number here. Let us look into the other details. After deleting 3 digits, the number from the right, the original number, the resulting number is divisible by 4. So again I have to put some numbers here, like how do you check this number is divisible by 4? When these 2 digits, the number formed by these 2 digits should be divisible by 4, divisible by 4. So in that case, again here there is a chance that 2 might come here, there is a chance 4 comes, there is a chance 8 comes here. So this is also a scene, this is also a scene. Now, after deleting 4 digits from the right, the resulting number is divisible by 3. So this number is divisible by 3. So you have to look for those numbers. You have to look for those numbers whose sum will be divisible by 3. So here anyways we are deleting 9 and we are not taking 5. So we are left with only 1, 2, 4, 7, 8. 1, 2, 4, 7, 8. And 2 or 4 or 8 will come here. 2 or 4 or 8 will come here. 2 or 4 or 8. So now among these numbers only, try to make a number which is divisible by 3. Try to make a number divisible by 3. Let us come to that later. After deleting 5 digits from the right, the resulting number is divisible by 2. So this number is divisible by 2. Again, there has to be one even number here. So even number here, and even number here. So we are left with only the odd numbers now. We are left with only the odd numbers. So those odd numbers are 1 and 7. 1 and 7. This and this has to be 1 or 7 for sure. For sure that has to be 1 or 7. And what about the middle number? If it is 1 and 7, what will be the middle number? This entire number should be divisible by 3. So 1 plus 7 is 8. So if you put 4 here, then only it is divisible by 3. 1, 4, 7, total is 12. So among 2, 4, 8, only 4 can come here. So 1 is done, 4 is done and 7 is done. Now, what about this number? When you see this number divisible by 4, you will look that these numbers, the number formed by this particular number formed by this particular digits should be divisible by 4. So 4 is consumed here. So 2 or 8. So 8, if I put 78 is not divisible by 4. So it has to be 2. If I put 2 here, 8 will come here. So the number is 1, 4, 7, 2, 5, 8, 9. 1, 4, 7, 2, 5, 8, 9. This is the number that we are looking for. And now the number is done. Look at what they are asking. Which of the following is a possible value for the sum of the middle 3 digits? Middle 3 digits. So middle 3 digits are these. 7 plus 2 plus 5. 7 plus 2 plus 5 is 14. 7 plus 2 plus 5 is 14. They are asking which of the following is a possible value for the sum of the middle 3 digits. So anyways, here we are checking 1 and 7. So that can be 7 and 1 also. In that case, 7, 4, 2, 5, 8, 9. 5 is fixed here. 5 is fixed here. No doubt about that. 4 is fixed here. 2 is fixed here. But 7 and 1 is there. 7 and 1 is there. So see whether this number is divisible by 4. Yes, this is also getting divisible by 4. So this is also a possibility. Then look at the sum of these. So here 7 to 5 is giving me 14. Here 1 to 5 giving me 8. In that case, there is a possibility that 8 is the answer. 8 is the answer. So here this problem is like very tricky, and it consumes a lot of time, and this is related to the divisibility of a number. So when a number is divisible by some number, then like what all properties it possesses. So when it comes to 3 and 9, sum of the digits. When it comes to 2, 4 and 6, last number has to be even. When it comes to 4, last two numbers should be divisible by 4. That is how we have to approach this problem, but it will consume more time for sure. Two friends, X and Y, start running and they run together for 50 meters in the same direction and reach a point. X and Y start running and they run together for 50 meters. So when they don't give the direction, take to your right 50 meters in the same direction and reach a point. X turns right and covers 60 kilometers. X turns right and covers 60. Y turns left and covers 40. Y is covering 40. Y is here, X is here. Then X turns left and runs 50. He is left. He is going like this, he is left. So that is 50. While Y turns right and runs 50. And then stops. How far are the two friends from each other now? So if you look at, these are two parallel lines and this distance is 100. So they are 100 meters away from each other. 100 meters away from each other. This is a very juicy problem and you should not be making mistake in such easier questions. Here, which of the dates of June 2099 among the following is a Sunday? For this, we have to remember one fact in calendar, that is 01/01/0001 is a Monday. This is a fact. This is when our calendar begins. So every 400 years, this calendar repeats again. So like that, 801 is a Monday. Then 2001 is also a Monday. 2001 is also a Monday. But when you go to a century, 2101, but this is closer to 2100. So when you go from this century to this century, you have to add 5 odd days. You have to add 5 odd days to get the date. For one century, you have to add 5. So those many odd days will be there. So here Sunday is there. Here Monday is there. Monday plus 5. So Monday plus 5 will get Saturday. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So Monday plus 5 is Saturday. Now I will try to go back to 2099. So that is 01/01/2099. I have to go back 2 years. But I am passing a crucial year 2100, which is supposed to be a leap, but this is not a leap. How? When a number is divisible by 4, then it is a leap. When that same number is divisible by 100, it is not a leap. Then when that number is divisible by 400, it's a leap. This fact we should know, otherwise we make mistakes here. So between 2099 and 2101, there is 100, that is 2100, but that is not a leap year. That is not a leap year. Simply for these 2 years, going back 2 years, you have to subtract 2. You have to subtract 2. So Saturday minus 2 is Thursday. This is where we land up now. 1st January 2099 is a Thursday. So from there we have to, so 01/01 is a Thursday, Now I have to jump to up to 6, that is June. So for January you will add 3. For odd days, 28 plus 3, that plus 3. Then for February you will add 0 because that is not a leap year. Then for March 3, for April 2, for May 3. This is where you land up in June now. 3 plus 3 plus 2 plus 3. So this is equal to plus 11. But when you divide by 7, the remainder is 4. So 1st June will be Thursday plus 4. So 1st June 2099 is Thursday plus 4. After Thursday, Friday, Saturday, Sunday and Monday. So 1st June 2099 is a Monday. Now we want a Sunday. If you go back one day, that will be 31st May. But I don't want that. But if you come 6 days forward, it will be 7th June 2099 and it will be a Sunday. So 7th June 1999, that is 2099 is a Sunday. Here we have to go from the reference date and we landed up in 2001, then 2101, then going back to 2099, we landed up in 1st Jan 2099. From there, you have to come forward another 5 months. So that day you check what is that. That is a Monday. So if you go back one day, Sunday will be there, but you will land up in May. So that is not right. So you have to go forward for 6 days. So that is 7th June. This is kind of a moderate level problem, but you should know the reference date. Otherwise, you will end up in getting confused because you don't have a reference. If you don't have that reference, you can go from today. For example, today is what date and what day. From there, you can go forward and check what day will be on a particular date in June on 2099. Next one, a bill for rupees 1,840 is paid in the denominations 50, 20, 10 notes. 50 notes in all are used. So totally 50 notes are used. Consider the following statements. 25 notes of 50 are used. So 25 into 50 notes. So this is 1,250. Then the remaining are in the denominations 20 and 10. So already 25 notes are used. I need another 25 notes to be used because I can use only 50 notes. And the maximum that I will try to use is 20 only because these are bigger denominations. So this will be 20. 25 into 20 is 500. So 1,250 is already paid plus 500, it will be 1,750. But I need 1,840. So this will not be possible. Next, 35 notes of 20. 35 notes of 20. So total amount is 700. And I need another 15 notes. I need another 15 notes. But I have to settle 1,840. Here 700 is paid. I need to pay 1,140 more. But only 15 notes are there. Maximum denomination is 50. 15 into 50. I will get 750. So that's it. Not more than that. So even this gets defeated. Then 20 notes of 10. 20 notes of 10. It will give me only 200. It will give me only 200. And the remaining are in the denominations 50 and 20. So I need maximum amount. So I'll use 50 rupees wala. So let's say 30 notes because 20 are already there. Maximum that I can use is 30. 30 into 50 is 1,500. So 200 plus 1,500, again it will give us 1,700 only. Even this is not possible. So they are asking which of the following statements are not correct. Here you have to be extra careful. Not correct means all of them are not correct. All of them are not correct. So the answer is this one. The digits 1 to 9 are arranged in 3 rows in such a way that each row contains 3 digits. So there are 3 rows containing 3 digits each. And the number formed in the second row, is twice the number formed in the first row. So when I do this into 2, I will get this number. Then the number formed in the third row is thrice the number formed in the first row. So when I multiply by 3 to the first, I will get this number. So this into 2 is this into 3 is this. Now, if only 3 of the 4 digits, 2, 3, 7, 9 are allowed to use in the first row. I want to use only these in the first row. 2, 3, 7, 9. So 4 numbers are there. 4 numbers are there and I have to use it for 3 places. That means at a time you are leaving one and arranging them. You will get many options there. How many such combinations are possible to be arranged in the 3 rows? So these have to be used by only these. So 2, 3, 7, 9. But here one clue is there. This into 2 will give this number. This into 3 will give this number. Here in this place, if I use 7 or 9, double of that will become 14. It will tend to become a 4-digit number. Again, 7 into 4 is 28, 9 into 4 is 36. This will also tend to become a 4-digit number. This is where the clue lies. So, I can use either 2 or 3 in the first place. I can use either 2 or 3. In that case, if I take 2 as the number, 2 as the first number, second number can be anything, but I will start with the smaller number among them, 2, 3, and this is 7. 2, 3, 7. Now double this number will get 474. Again, these two are repeating, so this is not my number. Next, I will take 2, 3, 9. 2, 3, 9. And double this number, 4, 7, 8. Still holds good. Triple this number, 9 3s are 27, 3 3s are 9. So here repeating. So this is also not correct. Next is 2, 3, 7, 2, 3, 9 is done. So 2, 3, 7 is done. 2, 3, 9 is done. So they are not possible. Now next number for me is 2, 7, 9. 2, 7, 9 or 2, 7, 3 or 2, 9, 3 or 2, 9, 7. I have to check these. Now among these 279. So 279, double of this is 2 9s are 18, 2 7s are 14, so 15. Then 2 2s are 5 5 8. No, it doesn't suit. Next number is 273. 273, you make double, it will be 546. Yeah, holds good. Make triple, it will be 819. Yes, all these digits are different. So this is fine. Then this is correct. 293. 293, double of this, 586, still holds good. 3 times of this. 3 times, 3 3s are 9. No, this is getting repeated, not correct. So this is also gone. Next 297. 297, if you take the double of this, this will be 594. 9 9 getting repeated. So this is also wrong. So 273 is correct. But this is not it. We have to start with 3 also. So I'll start with 327. So 327, double of this, it will be 654, still holds good. Then 3 times of this, 981. This also holds good. So 327 is correct. Next, 329. So 329, double of this is 658, still holds good. Then 3 times of this, this will be 987. 88 getting repeated, so wrong. Next, 379. 379. So 379, double of this will be 158. So 758. So not possible. So this is also wrong. Then 372. So 372, double of this is 744. This is also wrong. This is gone. Now next is 372 is done. 79 is then 392. 392, double of 392 is 784. Still holds good. 3 times, no, it will cross 1000 if I make 3 times. So this is also wrong. Next, last number is 397. When I make 3 times of this, this will also be gone. So we have to consider only 273 and 327. So how many such numbers are there? So there are 2 such numbers are there. This is also a complicated and pretty lengthier problem. You have to understand the veracity of this initially and try to gauge this problem earlier, and you have to take it up. Unnecessarily don't waste time in the beginning with tougher and longer problems. X and Y run a 3-kilometer race along a circular course. There is a circular course and whose perimeter is 300 meter, whose perimeter or whose circumference is 300 meter. Their speeds are in the ratio 3:2. They are running with the speed 3:2. If they start together in the same direction, they start, how many times would the first one pass the other, the start off is not counted as passing. So here they are running in the same direction. They are running in the same direction, and how many times they meet each other, or how many times the faster one cross the slower one, that is what is being asked. For this person to cover 300 meters, like, so when he finishes one round, so he might not have finished. But to cover 3 kilometers, the first person has to make 10 rounds. To cover 3 kilometers, the first person has to make 10 rounds. This person also has to make the 10 rounds. But by the time this person has made 10 rounds, definitely he'll be doing less than that. So in that case, we'll check. When this person covers, let's say 3 rounds, this person might have finished only 2 rounds. When he finishes 3 rounds, this person would have finished only 2 rounds. So when he finishes 3 rounds, he might have covered 900 meters, the other person would have covered 600 meters. So 900 meters is divisible by 300, 600 is also divisible by 300. That means after the first person covers this much and the second person covers this much, they will again meet here. This is the first time when they are meeting. First person has covered 900 meters, that is 3 rounds, and the second person has covered 2 rounds. Until then, they have not met each other. I'll give one more clue. When the persons are running in the same direction, they will meet less number of times compared to the number of times they meet while running opposite of each other. So this is pretty much practical. You can observe this in your day-to-day routine. Like when they are running in the same direction, the number of times they meet will be less compared to the times when they meet while running opposite to each other. So this is what is the general observation, general awareness. So when he covers 900 meters, he would have covered 3 rounds and he would have covered 2 rounds. Next time when they meet, this person would have covered 6 rounds. This person would have covered 6 rounds. So 1800 meters he would have covered, and this person would have covered just 1200 meters. So this person would have covered 4 rounds. When this person covers 9 rounds, this person covers 6 rounds. By the time he covers 9 rounds, 2700 meters has been done, and for this person only 1800 meters is done. So this is when they meet for the first time. This is when they meet for the second time. This is when they meet for the third time. So fourth time, by the time he covers 300 meters, he will finish the race. But this person is only just 200 meters. So when he finishes, he will be here. He'll be here. That is around 200 meters. So totally they will meet 3 times in the course of their race. They will meet 3 times. So how do you get it? So every 3 rounds, he will cover 2 rounds. Difference is 1. So here he has to make 9 rounds. He has to make 6 rounds. Then only they will meet 3 rounds. Next round, they will not meet again. So they only meet 3 rounds. This is how we have to approach. This is the application of the clock problems also. Because in clock, the minute hand moves faster. Hour hand moves slower. By the time minute hand cover 12 rounds, the hour hand would have covered only 1 round. Our hand would have covered only 1 round. That means they meet 11 times. They meet 11 times in 12 hours. In this case, by the time the faster runner covers 9 rounds, the other runner would have covered only 6 rounds. So that means the difference is 3. So they meet 3 times. They meet 3 times. So this is pretty confusing and not so easy problem. But if you approach it practically, this problem becomes very simple. Next, if the order of the letters in the English alphabet is reversed and each letter represents the letter whose position it occupies, then which one of the following represents Lucknow? Okay, we'll read once again. If the order of the letters in the English alphabet is reversed, that means we are starting from Z, then Y, X, and we end up in writing C, B, A. But earlier, the normal order is A, B, C, and we end up in X, Y, Z. X, Y, Z. Now, if you want to write Lucknow in this order, that means in this way, where do we get L? The same position. You have to see here and write that number. For this, you have to apply one particular trick. See, in this one, this will replace this will replace this will replace this, or vice versa. But look at the sum. A is 1, Z is 26, so it is 27. Similarly, C is 3, X is 24, 27. So what we have to look for here is our original word and the word that is formed later. They will make the sum 27 for each letter. For each letter, each corresponding letter, they will make the sum 27. In this case, Lucknow. So the letter L and the letter which comes here gives me the sum of 27. This is what is the approach. So 27 minus this. L's position in the alphabets is 12. So 27 minus 12 is equal to 15. So 15 is nothing but O. 15 is nothing but O. Next one. This U's position in the English alphabet, RSTU, it is 21. It is 21. The complementary of this 27 minus 21 is 6, is nothing but F. See, these two options gone. So now either this or this. If you look at the last digit, only that is changing now. Now look at W. So W's position, W, X, Y, Z, this position is 23. W's position is 23. Then 27 minus 23 is 4. So this has to be D. So only if you look at the last digit here, that's more than enough to conclude the answer. Next one. In a tournament of chess having 150 entrants, a player is eliminated whenever he loses a match. This is kind of a knockout. Whenever a person loses a match, he is out. Only one loss is enough to get out. But a person who wins the tournament, has to win every game, because this is a knockout series. It is given that no match results in tie or draw. So if there is a tie or draw, it will help us only in the league matches to arrive at the rank of those teams. But in knockouts, we have to get a certain result. Either yes or no. Either win or lose, we have to get it. So that is why they have given there is no tie or draw. How many matches are played in the entire tournament? So this is nothing to do with permutation, combination, or any kind of number system. It is simple general awareness. See, in this entire tournament, one person emerges as a winner. How many of them lose? If they lose one match, they are out. So 149 people are out. So 149 people lose. That means 149 games are played. When 149 people go home after losing, that means they have played those many games. So for each game there will be a winner and there will be a loser. But total in this tournament, 149 losers are there. 149 losers are there. Or to put it across, there is only one winner, 149 unsuccessful people are there. So 149 people will go out, but as a result of their match. That means they have lost that match. So 149 matches are possible. You do in whatever the fashion. However, you make a tie between two teams. Tie between means like however you make A versus B, C versus D, like that. You will end up in conducting 149 matches if this is a knockout round. If it is a knockout round. For example, I will tell you, if there are 8 teams A, B, C, D, E, F, G and H. So generally, how do you conduct? First match, second match, third match and the fourth match. Winner of this, then winner of this. 4 matches, 2 matches, 1 match, 7 matches. How many teams are there? 8. So 7 match, how to be conducted to eliminate? Or will make A versus B, winner will play with this, 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 winner will play and winner will play. So finally 1, 2, 3, 4, 5, 6, 7. So in whatever the fashion you want to conduct the matches, anyways you will end up in making n minus 1 games. N is number of players. When those many number of players are there, you have to just conduct only 1 match less than those numbers. 1 match less than those numbers. So that is what is the clue. Here we have to conduct 149 matches to get the clear winner. Next one. How many 3-digit natural numbers are there? How many 3-digit natural numbers are there without repetition of the digits, such that each digit is odd and the number is divisible by 5. You want a 3-digit number and each of the digits is odd. So how many odd digits are there? 1, 3, 5, 7, 9. 5 digits are there. There are 5 digits and you want that number to be divisible by 5. So if you want this number to be divisible by 5, it should end up with 5 or 0. But among the given odd numbers, only we can put 5. We can put only 5. Now, how many 3-digit natural numbers are there such that each digit is odd? We are going to use this only and the number is divisible by 5. So now 2 places are there and 4 numbers are there. So among these, any one can be used here. This can be filled in 4 ways. And we should not repeat the number of digits. So this can be filled in 3 different ways. So 4 into 3. So 12 different ways we can fill this places. So anyways 5 is fixed in the unit digit. So other 2 numbers can be anything about among this 1, 3, 7, 9. So first place can be occupied 4 ways, second place can be occupied 3 ways. So 4 into 3 is 12. Okay, this is also data insufficiency problem. Consider the question. They are asking whether x is an integer. Is x an integer? We should be able to tell yes when in all 100% cases it will be an integer. We should say no in all 100% cases if it is a fraction. As simple as this. In one case if you get integer, in another case if you get a fraction, you cannot answer this question. So either your answer has to be yes or no. If it is integer, it should be integer in all cases. If it is a fraction, it should be a fraction in all cases. As simple as that. So now statement 1 alone. Check statement 1 alone. X by 3 is an integer. X by 3 is an integer. So when x will be an integer or x will be a fraction, that we need to find out. Okay. So this has to be integer. That means this x has to be a multiple of 3 because I can cancel. If x is 3, 3 by 3 is equal to 1. If x is 6, 6 by 3 is equal to 2. So they are asking us that whether x is an integer, and they have given x by 3 is not an integer. X by 3 is not an integer. So when x by 3 is not an integer, then it can take any value like 1, 2, except 3. If I take 3, this will become integer. 3 by 3 will become integer. 6 by 3 will become integer. 1, 2, 4, 5, skip 6 again. 7, 8, skip 9. Then 10, 11, skip 12. Like this it will keep on going. Only when there is no multiple of 3, then only it can be a fraction. So can I tell x is an integer? And they are telling this is not an integer. But why should I take only the integers? For x by 3, if I take x as half, still half by 3 is 1 by 6. This is not an integer. So x can take all these integral values, plus it can take any fractional value also. So in this case, x is both integer or a fraction. So statement 1 alone, I cannot answer anything. Statement 1 alone, I cannot answer anything. Here x can be any number except the multiple of 3, and x can be a fraction also. In that case, can you say x is an integer? No, it can be fraction also. Now, next statement. Statement 2 alone. 3x is an integer. 3x is an integer. 3x is an integer. So now check for what all values of x it will be an integer. If x is integer, definitely 3x will be integer. If x is an integer, then 3x is also an integer for sure, because 3 times of x will be an integer. 3 into integer, it will be integer. But is there any chance of this to be a fraction? Is there any chance of this to be a fraction? For example, 3 into 1 by 3. 3 into 1 by 3. 3 get cancelled. This is 1. This is an integer. 3 into 2 by 3. 3 get cancelled. It is 2. So like this, there are chances that the x can take a fraction value also. So x is both a fraction and an integer, or fraction or integer. So statement 2 alone will not help us to solve. Statement 2 alone will not help us to solve. So even that is not the answer. Now we need to club both the knowledges. So in first one, what I got is x can take any value like 1, 2, 4, 5, 7, 8 and so on. And it can be a fraction also. It can be anything and any fraction also. In this case, this will be an integer only when this will be 1 by 2, 1 by 3, 2 by 3, then 4 by 3, and also when all integers. See here you see, in this case, it has to be an integer. It has to be an integer like except 3, 6, 9, except multiples of 9. Here it can be any integer. So in this case, this is a smaller set, this is a smaller set. Okay. So x can take any value of this. I will forget this. Now, this can be any fraction. This can be any fraction. In this case, this has to be these particular fractions only. That means it can be a fraction also. So even combining both the statements, I am getting like some as integers and some as fractions. So even now I cannot conclude that x is a fraction or an integer. X is a fraction or an integer. I cannot conclude. If they ask, is x an integer? I don't know. That means even by combining both the statements, I cannot get to the answer. Okay. Be careful in such questions. They are both time consuming and confusing questions. Now, the increase in the price of a certain percent was 25%. Then the price was decreased by 20%. And then again increased by 10%. Simple. First of all, a particular thing is increased by 25%. So it will become 125 by 100. Next, this is decreased by 20%. Then the effect will be 80 by 100. Then again, it is increased by 10%. So effect is, now what is the resultant increase? Okay. So we'll try to cancel 0, 0, 0, 0 cancel. Then 25 4s and 25 5s, 5 1s, 5 20s, 4 1s, 4 2s, 2 1s, 2 10s. So basically this is 11 by 10. 11 by 10 is nothing but 1.1. That means still it is increasing by 10%. Still it is getting increased by 10%. I'll tell one more thing. See this 125 by 100 increase and the decrease of 20%, that is 80 by 100. So anyways this is 10,000 by 10,000. This is nothing but 1. There is no change after these two increase and decrease. Only change is this 10%. That is why the resultant is 10% increase. The letters A, B, C, D and E are arranged in such a way that there are exactly 2 letters between A and E. How many such arrangements are possible? See, there are 5 letters. 1, 2, 3, 4, 5. And there are exactly 2 letters between A and E. How many such arrangements are possible? See, if A and E are there, exactly 2 letters are there. So among 5, 4 places are fixed. And when they say between A and D, you need not be just considering A first and E later. So it can be E and A also. So exactly 2 letters between. The letters A, B, C, D are arranged in such a way that there are exactly 2 letters between A and E. How many such arrangements are possible? Okay. If you take like this, let's say A dash dash E. Now, where will the 5th person come? 5th person can come here also. Similarly for E and A. Now, if it is again A and E, then the 5th person can come here also. And if this is E and A, 5th person can come here also. So these are the possibilities that we have. So 4 different arrangements, but yet we have not filled BCD. We have filled only AE. For BCD, there are 3 places. So 4 such arrangements, and in each arrangement, these 3 places can be filled in 3 factorial ways. These 3 places can be filled in 3 factorial ways. So here BCD or interchange them. So 4 into 3 factorial. So 3 factorial is nothing but 6. So 4 into 6. So there are totally 24 possibilities are there. You have to be very careful here. When we say A and D, order is not sacrosanct. A comes first and E comes later, that is not sacrosanct. So even E can come first. Then after these 4 letters, the 5th letter can come, or before these 4 letters the 5th letter can come. So 4 such arrangements are possible, but in each of the arrangements we have to fill again BCD. So totally it is 24. 4 into 3 factorial, that is 24. Consider the questions. Consider the question and 2 statements given below. Okay. So is Z brother of X? We have to see whether Z is brother of X. X I don't know, whether male or female I don't know. But if we come to a conclusion that Z is brother of X, that means first of all we have to ascertain that Z is a male. Z is a male. Then you can understand that Z is a sibling of X. So male sibling is a brother. So you have to ascertain 2 things here. Z is a male and Z is a sibling. Now, statement 1 alone. X is brother of Y. Male, for male I am marking minus. X is brother of Y and Y is brother of Z. Okay. So these are 3 siblings. Don't tell that Z is a brother. X is male, Y is male. We know only that much. But what about Z? It can be anything, male or female. In that case, Z is sister of Y. Z is sister of Y or Z is brother of Y. Can I answer this question certainly? Is Z brother of X? I don't know. It can be both brother or sister. So statement 1 alone will not help. Now forget the statement 1. Now X, Y, Z are siblings. X, Y and Z. X, Y and Z are siblings. But I don't know their gender. I don't know their gender. So can you answer only with statement 2 alone? No, we cannot. But statement 1, try to club with statement 2 now. So here also they have given X is brother of Y. Okay, same thing. Y is brother of Z. We are not getting any extra information even by clubbing both the statements. In the first one, at least we know the genders of X and Y. But in the second one, we don't know even the genders of X and Y. So basically the first statement is a subset of the second statement, or like both are telling almost the same thing, but second statement is still hiding some information that A is revealing. Even by combining both the statements, you cannot get any clue. So in this case, like D is the answer. D is the answer that says that both statement 1 and 2 are not sufficient to answer the question. 26. On one side, 1.01 kilometer long road, 101 plants are planted at equal distance from each other. What is the total distance between 5 consecutive plants? See here, there is 1.101 kilometer road. So total is 1.01 kilometer. That is nothing but 1010 meters. 1010 meters. And you are planting 101 plants. 101 plants. So the first plant will come here and 101st plant will come here. So if you look at the gap between two consecutive plants, how many gaps will be there? Between 1 and 2, 1 gap. Between 2 and 3, 1 gap. So like that, between 1 and 101, there will be 100 gaps. There will be 100 gaps. The first point is first plant, last point is last plant. In between 100 gaps are there. So this 1010 meter is accommodating 100 gaps. 100 gaps. That means 0, 0 get cancelled. So each gap is giving me 10 meter. So what is the length of each gap? Length of each gap is 10.1 meter. This is what we have to understand. Now, what is the distance between 5 consecutive plants? So first plant is here, second plant, third, fourth and fifth. So how many gaps? 1, 2, 3, 4 gaps. 4 gaps of 10.1 meter each. So 10.1 meter into 4. So 40.4 meter. 40.4 meter. Here people tend to make mistake. When they take 101 plants, they will take 101 gaps and they will calculate the gap of 10 meter each. But that is wrong. And here we are planting 5 plants. So 4 gaps will be there. So 4 gaps of 10.1 meters each. So 40.4 meter is the gap. So one of the very good questions here in this paper. Next. A, B and C are 3 places such that there are 3 different roads from A to B, 4 different roads from B to C and 3 different roads from A to C. So all these are connected well to each other. So let me draw a triangle A, B and C. There are 3 different roads from A to B. So A to B, 3 different roads. Then 4 different roads from B to C. Then 3 different roads from A to C. 3 different roads from A to C. So here they are asking in how many different ways can one travel from A to C. So A to C, these 3 roads are already there. So these are 3 ways of going from A to C directly. But If these roads are cut, then A has to be connected to C via B. So if one wants to travel from A to C, that person has to travel through B. In that case, how many ways are there from A to B and B to C? 4. But here people do this mistake. They will add 3 plus 4. No. Now, if this person take this route, he can take this route also, this route also, this route also, this route. For every route from A to B, there are 4 possible ways from B to C. So, 3 possible ways from A to B into 4 possible ways from B to C. So, 3 into 4 is equal to 12. These are 12 ways of reaching C via B and 3 routes directly. So, totally we have 15 routes to arrive at C from A. So, this is how we have to think. Otherwise, people will do 3 plus 4, that is 10, but that is wrong. So, to go from here to here, your journey will be finished only when you reach C. So, 3 ways and 4 ways, they have to be multiplied. But here in this case, there are 3 different ways, that's it. We are not multiplying anything. So, 3 plus 12. So, totally 15 different ways. A has some coins. If he gives half of the coins and 2 more to B, okay, A has some coins. He gives half of the coins and 2 more to B. B gives half of the coins and 2 more to C. C gives half of the coins. So, every time one operation is happening and we are repeating that operation. So, here A has some coins and he gives half of the coins and 2 more to B. Now, this is what the B has. This is nothing but B. Now, B gives half of what he has and plus 2 to C. This is what C has now. Now, this is divided by 2 plus 2. This is what the D has now. Is the smallest 2-digit number. The smallest 2-digit number is 10. Smallest 2-digit number is 10. So, this is the operation. So, in this case, what we can do? Every time subtract 2 and multiply by 2. So, when I subtract 2, it will be 8 and it will be multiplied by 2, it is 60. Now, again subtract by 2, that will be 14. Multiply by 2, that will be 28. Again one more time, subtract 2, 26 into 2, it will be 52. 3 iterations. So, this is the first iteration, this is the second iteration and this is the third iteration that I am doing. So, finally we will get it as 52. But here there is a chance that people will get confused believing that B had already some coins and C had already some coins and D had already some coins. No, in this case they have not given. Directly they have started A has some coins. That's it. B, C, D, we don't have anything. So, in that case, whatever A gives to B, that is the treasure of B. Whatever B gives C, that is the treasure. Whatever C gives D, that is a treasure. This is how you have to calculate. In the series A, AB, ABC, ABCD, ABCDE, if you go on writing like this, which letter appears at the 100th place? Which letter appears at the 100th place? Now, you check 1 letters, 2 letter, 3, 4, 5. Next is 6 and will end up in F. But what is the total? What is the total? 1 plus 2 plus 3 plus 4 plus 5 plus 6. So, totally we have 21 up to this. So, 21st letter will be F. Now, I will add 7. 28th letter will be G. Now, I will add 8. I'll add 8. 36th letter will be 36th letter. F, G is done, H. Now, go on doing like this. So, when you go on doing like this, we'll definitely get one particular this thing, but we have to add. After finishing one number, that is A. After finishing 2, we'll get B. After finishing 3, we'll get C. After finishing 4, we'll get D. So, A, B, C, D. But totally how many letters? Totally how many letters? 1 plus 2 is 3. Then 3 plus 3 is 6. 6 plus 4 is 10. So, totally I have written 10 letters, but my ending letter is D. So, similarly, for 5, I get 15. For 6, I get 21. So, these are the number of letters that I have. Then 7, it is 28. Then 8, it is 36. Then 9, it is 45. 10, it is 55. So, what does it mean now? What does it mean? So, here when I write A, B, C, D, E as my fifth group, A, B, C, D, E as my fifth group, I have totally 15 letters. I have totally 15 letters. So, I need the 100th letter. I need the 100th letter in the series 1, 2, 3, 4, 5 like this. So, when I end up in F, I got 21 letters. When I end up in G, I get 28 letters. And when I end up in H, I get 36 letters. Then when I end up in I get 45 letters. When I end up in J, I get 55 letters. Now I have to get the 100th letter. I have to get the 100th letter. So what is happening here? See, here, this is nth letter, 5th letter. Sum is n into n plus 1 by 2. N into n plus 1 by 2. N into n plus 1 by 2. So similarly here, 10 into 11 by 2. So I need 100. I need 100. Look at that number which might give me like 14 into 15 divided by 2. 2 ones are 2 sevens are, it is 105. So which letter is 14th? 14th letter is N. So when I finish N, like my sum will be 105. So this is what I have to get here. So N letter is 105th letter. N is 105th letter. So if you go back, M is 104th, then L is 103rd, then K is 102nd, J is 101st, and I is 100th letter. I is 100th letter. It is not that easy. It is not that easy. This is the application of the sum of first n natural numbers, that is n into n plus 1 by 2, and my target is 100. So which is that number which will give me n into n plus 1 by 2 close to this 100. So that number is 14. So 14th letter is n. So 14th letter is in n, that means 105th letter is n. So 105th letter is n, so 100th letter will be I. It is not that easy to get, so you have to practice a lot for this. So for that you should have a good relation between alphabets and numbers. That is, like at what order of the alphabet, like what comes. So A is 1, like that, J is 10, T is 20, like that you have to remember the order of these letters. So if you remember a few, first 6 letters A to F, 6 letters you can remember. Last 3 letters X, Y, Z. So 24, 25, 26 you can remember. Then I is 10th, T is 20th. Then you remember other 2, 3 good alphabets which are closer to you there. order, then that will help you. 3 persons, A, B, C, standing in a queue, not necessarily in the same order. Not necessarily in the same order. There are 4 persons between A and B. This is again a very complicated problem. You have to be very careful here. When we say A, B, C, they are not standing in the same order. So that can be anything. These 3 people can stand in whatever the way they want. For example, A, B, C here, A, C, B here, then B, C, A, B, A, C, C, A, B, C, B, A, in whatever the manner they can stand. Now, they are telling there are 4 persons between A and B. Let me start constructing this diagram. Between A and B, there are 4 persons. There are 4 persons. And if you reverse the case, between B and A, there are 4 persons. Now, and 7 persons are there between B and C. So, B and C, if I write, so there are 7 persons here, but if I bring the 7 here, C will come here. So, 7 here, 4 here, 4 here, 7 here, and there is one more chance. If I keep A and B like this only, and 4 persons are there in between, but between B and C, I can take this C, this side, 4 people here, A one more, another 2 will come here. And now, what I can do, A, B, C is here, or A, B, C is like this, or you can reverse this scenario, B and 4 persons here, A here, then C, in between 2 persons are there. So, these are 4 different scenarios that we have right now. Now, if there are 11 persons ahead of C, let's say C is here, in this case, there are 11 persons ahead of C. Here also 11 persons ahead of C. In this case, in this case, there are no 7 persons ahead of C. There are no 7 persons ahead of C. So, here you can write 11 persons. Then, here also you can write 11 persons. But one chance is there. One chance is there. How do you count? This way. This way. Only in this case and this case. For example, C is here and 2 persons here, A is here, 4 persons here, and B is here. So, totally 8 persons. Another 3 persons will be there in front of C. 8 persons here and here. So, even in this case, if you reverse the case, here C, then 2 persons, A, then 4 persons, then B, then other 3 persons here. So, these are the 6 ways that we have. And 13 behind A. See, when 11 persons are in front of C, then behind A are 13. So, in this case, behind A, like there are 5 persons. So, here another 8 persons. Here behind A, 13 persons. And here behind A, 13 persons. Here behind A, B and 4. So, 5 persons, another 8 persons here. Here behind A, C and 2. C and 2 are there. So, 3 persons. So, 13 persons means another 10 persons. In this case, in front of C, these many people are there. At the back of A, again 10 persons are there. So, this is what we get. What could be the minimum number of persons in the queue? So, now count A, B, C, 3 persons plus 11 plus 2. 3 plus 11, 14 plus 2, 16 plus 4, 20, 28. 28 is one case. Next, A, B, C, 3 persons, then 13, 16 plus 4, 20, 27 and 11, 38. So, this doesn't qualify. Next, A, B, C, 3 persons, then 11, 14 plus 7, 21, 21 plus 4, 25 plus 13, 28. Sorry, 38. That is not possible. Then ABC 3 persons, 3 plus 8 11, 11 plus 4 15, 15 plus 2 17 plus 11 28 is a possibility because that is the smallest among all. Now ABC 3 persons plus 3 6 plus 4 10, 10 plus 2 12, 12 plus 10 22. Now new small sum is 22. Similarly, ABC 3 persons, 3 plus 10 13, 13 plus 2 15, 15 plus 4 19 plus 3 22. So the minimum number of persons that we can have is 2. See, there are 6 ways of arranging ABC, not just one way. There are 6 ways of arranging ABC and they have given some data. According to that, we have to fill here. According to that, we have to fill here. And finally, we get 22 as the minimum number of persons that we can accommodate here. Maximum we have 38. Minimum is 22. How many seconds are there? They have given weeks, days, hours, minutes, and finally seconds. So, if I take x seconds here, x seconds, then I'll take x minutes. So, x minutes means 60, x seconds, x hours, 60x, these are the seconds in minutes. Then if I take hours, every hour has 60 minutes. So this is 3600 x seconds. Now days. So each day will be having 24. So if you multiply 24 to this, 24 6 are 144, 24 3 are 72, 86,400 x seconds. Then x weeks, that means we have to multiply by 7 here. 7 4s are 28, 7 6s are 42, so 44, 7 8s are 56 plus 4, that is 60. These many seconds. So add down, x will remain here, but here you have to take this as 1x, not just x. 1 here, then 6, then 6 plus 4 plus 8 is 18, 6 plus 4 plus 3 plus 1 is 14, then 69. So this is 6,94,861 x seconds. This is straight away the multiplication and the addition problem, but bit confusing because what confuses you is like for x you have to take that as 1x, then 60x, 3600, then into like 24 into 7. So finally we will get this much. P, Q, R, S, T, U are 6 members of a family. R is the spouse of Q. R is the spouse of Q. So you have to have some notations to form a family tree. For spouse, I take a curved line and I don't know the gender of R and Q because they are just spouse. U is the mother of T and S is the daughter of U. U is the mother of T and S is the daughter of U. U is the mother of T and S is the daughter of U. So U is mother and S and T are the offsprings. So S is a sister there, T I don't know. And R son P. P's daughter is T. P's daughter is T. So U is mother of T and P's daughter is T. So that means this is a couple. This is a couple. So here we have RQ, here PU, ST. Then R son P. R son is P. P's daughter is T and R son is P. R's son is P. But I don't know the gender of R at R son is P. So how can I connect? R son is P. Then he married to you. Then for them we have the children S and also T. But we don't know. 6 members of a family. R is the spouse of Q and U is the mother of T. Okay. Then P's daughter is T. P's daughter is T. Yeah. And R son is P. R son is. There are 2 couples in the family. So this is one couple. This is another couple. Then which one of the following is correct? Q is grandfather of T. I don't know the gender of Q. Q is grandmother of T. I don't know the gender. R is the mother of P. No, I don't know whether father or mother. Then definitely T is grandmother of Q. T is the granddaughter of Q. Yes, this is a female and it is a granddaughter. Next question. How far is P from Q? What is the distance between P and Q? This is what they are asking. Then statement 1. City Q is 18 kilometers from R. City Q is 18 kilometers from R. This is what we know. But with this, can I answer this question? No. So statement 1 alone is not possible. Forget this. Now, city P is 43 kilometers from city R. Okay, P and R is there, but about P and Q, I cannot. So club both the statements now. This is what we have. QR is 18, PR is 43. So this is one way of writing it. Q and R, distance is 18 and P and R is 45. So remaining 43, sorry, remaining 25 is this. But this is not the only way that I can write. So if Q and R is 18, then P and R can be 43. P and R can be 43. So these are 2 ways of representing. So here they are asking how far is P from Q. In this case 25. In this case 18 plus 43, that is 61. Can I answer how far? I am getting 2 answers. One is 25, one is 61. So I cannot answer even by using both the statements. So that is where it goes wrong. Now, this is a problem associated with syllogisms. So statement 1, all pens are books. All pens we have is book. All pens are books. So some books are pens, that's all. No chair is a pen. So there is no logical connection between pen and a chair. So they have to be distinct. All chairs are books. All chairs are books. So all chairs should be books. So all pens should be books and all, sorry, they are giving this as a conclusion. I am sorry. These are only the statements. So you have to be careful. Otherwise you will end up reading conclusion like me. So no chair is a pen. So chair has to be somewhere outside, or this is P, this is B, and this can make, but it should not coincide with P. Or this also a possibility. P and C are distinct and B is over this. This is also a possibility. Let us check the conclusion. If conclusion doesn't follow one of the diagram also, not at least one diagram, that is wrong. All chairs are books. No. There is no logical connection. Some chairs are pens. There is no connection between chair and pen. No chair is a pen. All books are chairs. No, need not be. Need not be. No chair is a book. No chair is a book in this case. But in this case, I can combine B and C. Or chair can be taken inside this one. So, even that is wrong. So, none of the conclusions follows. None of the conclusions follows. Similar problem. Similar problem. Some doctors are teachers. Some doctors are teachers. All teachers are engineers. All teachers are engineers. This is a possible diagram that I can have. And some scientists are doctors. Some scientists are doctors. These are the exclusive diagram I have. Sorry. See, again I have committed the mistake here because I am reading the conclusions. So, don't do this mistake. In the examination hall, in hurry, you will combine both the statements and conclusions. So, now all teachers are engineers, some doctors are teachers, and all engineers are scientists. All engineers are scientists. This is what we can draw. This is what we can draw. Now, conclusion. Some scientists are doctors. Definitely some scientists have to be doctor because these two are intersecting. So, the outer circle will definitely intersect. All engineers are doctors. No, all engineers need not be. Some engineers are doctors. I cannot say all engineers are doctors. Some engineers are doctors. Yes, for sure, some engineers are doctors. So, in this case, don't apply your general knowledge. How can be a doctor an engineer? How can be an engineer a doctor? So, don't apply your brains here. So, simply go by the given facts. That's all. Even if they are defeating your general knowledge, that's okay. So, here conclusion 1 and 2 follow. Conclusion 1 and 2 follow. Next one. 8 students A, B, C, D, E, F, G, H are sitting around a circular table. So, whenever they are sitting around a circular table, make this arrangement like this. Equidistant from each other, facing the center, not necessarily in the same order. B and D sit neither adjacent to C nor opposite to C. So, if C is here, B and D will not sit here, neither here. So, the place occupied by B and D are somewhere among these 4 places. A sits in between E and D. A sits between E and D. This is one possibility, or A sits between D and D. So, they will just go like this. Then, F sits between B and H. F sits between B and H. So, even these 3 people are together. These 3 people are together. So, these 3 people and these 3 people. How do I make them sit? These 3 people can be here and other 3 people can be here. Or if these 3 people are here, other 3 people will be there. If these 3 people are here, other 3 people will be here. So, basically, I have 4 possible ways of making these groups sit. But the remaining person is what? 3 persons are here, 3 persons are here, and C is there. The remaining person is G. Remaining person is G. When they are occupying these 3 continuous places and these 3 continuous places, G will come here. When they take these 3 and these 3, again G will come here. When they take these 3 and these 3, G will come here. So, G has 3 places here, either adjacent to C or opposite of C. This is where the G comes. Now, look at the statements. B sits in between A and G. I can't say B is here, B is here. He sits between A and G. No, A is in the middle, either next to E or D. So, that is wrong. C sits opposite of G. Yes, this is a possibility. This is a possibility, but not all the times. When they say sits, this is definite. So, even G can come here. E sits opposite of F. No, not possible, because F is in the middle. F is in the middle and E is at the extreme here. So, there is no possibility. There is no possibility of all the times they cannot be opposite. So, they can sit opposite to each other, but not all the times. Now, none of the above. Yeah, all these 3, this is not a possibility at all. There is a chance, but not all the times. There is a chance, not all the times. If they tell C can sit or C may sit, here A can sit or A may sit, then there is a possibility. But otherwise, when they say definite, no, it is not definite. So, this is how we have to conclude. So, other half of the paper we will see in the next session. So, until then, please keep on revising whatever that we have discussed. So, if you look at these videos alone, so if you understand the concepts what I am trying to explain here, I think this is more than enough for your revision of the PYQs. You don't have to refer any other thing. Thank you so much. All the best.